Welcome back, Pre-Calculus. We are picking up here at a lesson 1.2. This entire lesson is about analyzing graphs of functions and relations, which is something we've done in Algebra 2 and Algebra 1. So it should be a nice review for you. We've got a multitude of different things that we are going to do, but in example 1, get back up to it. In example 1, we're estimating values of a function. And so all that really means is if we're given an x value, we're going to use a graph to approximate what the y value is. If we're given a y value, we're going to approximate the x value from the graph. So it says consider the graph of the function r of x is equal to 17.7 x cubed minus 269x squared plus 1458x minus 910. Notice those aren't happy whole numbers. It's really big numbers. So if we were trying to do this without a calculator, it'd be challenging. So sometimes we just want to look at a graph and make some approximations as to what the value is. And that's what they're asking us to do here. It says use the graph to estimate the total internet advertising revenue in 2007. Well, if you notice here at the bottom, it says years since 1998. So I'm not looking for 2007 on my x-axis. Instead, I'm going to count up how many years is it since 1998, and then that's going to be the x value I look at. So 2007 is 9 years after 1998. And so if I go up onto the graph at when x is equal to 9, I come over here to the y-axis, and it looks like we're approximately around 3,300. So I would say R of 9, or my revenue after 9 years, is approximately equal to 3,300. Now, as we go into calculus, it's going to become extremely important to make sure we put on our units. If we're given units in a problem, we need to have units in our answers. So approximately 3,300 what? Well, our unit here is millions of dollars. So 3,300 millions of dollars. All right. And then it says, great, now confirm that estimate algebraically. And all they mean is with your calculator, we're going to plug 9 into the calculator. That would be 17.7 times 3 cubed minus 269 times 3 squared plus 1458 times 3 minus 910, running out of room there. And when we plug that into our calculator says, and why am I putting the approximation? Because it's a decimal that keeps going on and on. So I'm going to approximately round it to 33. Let's try that again. 3326.3 million dollars. All right. How often do we say 3,326.3 millions of dollars? Not often. Typically, once we get past hundreds of millions of dollars and we're into thousands of millions of dollars, we turn it into what? What's the next biggest unit there? 3.326, let's call that billion dollars. That's our revenue. So how did we do? Were we close with our estimation of the graph? Yeah, pretty close. I mean, we were off by $26.3 million, but in the context of this problem, that's not a huge number, right? Okay, getting used to this board. All right, for B, it says, use the graph to estimate the year in which total internet advertising revenue reached $2 billion. So now they're asking me to find the x value at a y value. I'm going to come over here to where my y is 2000, and I'm going to say that is approximately 7 years since 1998. So 7 years after 1998. And what year would that be? So 7 years after 1998 would be 2005. And again, it wants me to confirm the estimate algebraically. So we're going to put in f of 6. And we're going to put in f of 7. And then we're going to make sure that between those 2 years, between 2004 and 2005, we go past that $2 billion mark. So 17.7 times 6 cubed minus 269 times 6 squared plus 1458 times 6 minus 910. And we're going to do the same thing with 7. This is just a matter of plugging it into our calculator. And the calculator is going to spit out the following for us. So f of 6 is about 1977 million, or 1.997 billion. And then f of 7 is about 2186 million, or 2.186 billion. So between years 6 and 7 after 1998, which would be 2004 and 2005, we hit that $2 billion point. All right, let's do one more. Actually, this is your you try. So I'm going to stop the video here, and I want you to try this one on your own and come back and watch the next video when you think you have it.